let's do the next question. See here, they've given you one determinant. Also verify that A11, A31. So here a small letter A represents the element. Capital letter A represents the cofactor corresponding to that particular element. Okay, we need to do this one. Now, first thing what we'll do, we'll calculate what is the minor and what is the cofactor. Of course, you can directly calculate cofactor if you are okay with it, or do minor and then do cofactor. Okay. Now, in this one, so first thing what we do, we calculate A31. So for A31, this is equal to minus 1 to the power of 3 plus 1. And then, see, A31 is what? Third row, first column. Third row, first column. So you get minus 3504, correct? We do minus 3504. Minus 1 power 3 plus 1 is just 1. Then you're going to have 1 into minus 12, which is minus 12. This is the first thing. Next, we need A32. So A32 minus 1 to the power of 3 plus 2. Again, in the determinant, third row, second column, correct? So when you remove it, you'll get 2, 5, 6, 4. Minus 1 into, you'll get 8 minus 30. Minus 22 into minus 1, the answer becomes 22. Next is A33 minus 1 to the power of 3 plus 3. Determinant of, so 3 and 3, you have 2 minus 3, 6, 0. Anyway, minus 1 power 3 plus 3 is 1. So you have 0 plus 18. So answer becomes 18. This is what we have. Now what we are trying to do, see, we are trying to calculate the value of A11. So that means, guys, I'm trying to solve this one now. The A11 is 2. So you have 2 times minus 12 plus 22 times minus 3 plus A13, A33. 5 times 18. This is what we have to calculate. Then you have minus 24 for the first one, minus 66 for the next one. Next, this is going to become plus 90. Now, 24 and 66, when you add, you will get minus 90. Minus 90 plus 90, the final answer becomes 0. So this becomes the final answer. So what you're seeing right now is the proof, the verification and the proof. Got it? See, they can also ask you find the determinant using without expansion. In such cases, take the element and the corresponding cofactor. Okay, the element and the corresponding cofactor. So we'll try to calculate another, like we'll try to do one more problem where we calculate the determinant without actually expanding, just by using the cofactor. Okay, so we'll do it. You guys are going to see that right now. See this particular question. See, using cofactors of elements of third column, evaluate. So third column is this. We have to use those elements and calculate what is the determinant of this particular matrix. Okay, so now let's do this one. So first, what do? We calculate. So what exactly is the relation? So the relation is basically delta is equal to, so in this case, only the third column, right? A31 into A31, first one, plus A32. What do we get? We get delta A13, first row, third column, A13 plus A23, capital A23 plus A33, capital A33. First, let's calculate A13. Okay, so we have A 1, 3. See, minus 1 to the power of 4 anyway, so no need of writing it. Determinant of, remove the row, remove the column. So remove the row, remove the column. 1y, 1z, which basically becomes z minus y. So 1y, 1z. So this is going to become z minus y, first one. Next is A23. So when it's A23, remove the row, remove the column. 1x, 1z. That's basically z minus x, correct? So now what do we have? This becomes minus 1 into z minus x. Or you can also write this as x minus z, as simple. Next, same thing, when you take A33, you're going to have, see, minus 1 power 1 plus 1, that's anyway there. Then take off the row, take off the column. 1x, 1y, which becomes y minus x. So this becomes y minus x. Now let's apply the formula here, because the formula is A13 into A13. A13 into A13, correct? So this becomes A13 is what? YZ. So we have YZ. We have YZ into, so this becomes Z minus Y. Next is plus XZ into X minus Z. Next is what? Plus XY into Y minus X. Now we have been asked to evaluate this particular value, isn't it? So what do we do? See, evaluation comes, you guys have to take common, you guys have to do a little bit of manipulation, and then we have to do it. So in this case, y into z square minus y square into z. X square into z minus x into z square. Next is plus x into y square minus x square into y. Okay, now here you can take couple of things common. So in the sense, when I say a couple of things common, maybe you can take common, such as, see here, x square and x square is common, y square is like this, you will have to take common. Okay, let's do this one. First, if we take x square common, so you're going to have x square into z minus y. Next, we'll take y square plus y square into x minus z. Plus next is z square into y minus x. So the same thing, we are just rearranging in a different form. Okay, now this becomes the expansion of the determinant. Guys, I'll tell you one more thing. This can be further simplified. Okay, this can be further simplified by taking x minus y common. We can do a lot of simplification. Okay, so the final answer you will get in terms of x minus y into y minus z into z minus x. You are going to get in terms of that. But right now we are not looking into it. That's why I'm going to keep it as it is. Okay, I'm going to keep it as it is, because see here, to be honest, we can do a lot of combinations. One example I'll tell you here. See this one. If you take z common, you'll get x square minus y square. X plus y into x minus y. You can take that common. Okay, likewise, we can do further simplification. It's not that we cannot, but then right now, I'm just keeping this in the expanded form of the value of the determinant. That's all. Okay, so don't assume that this answer is not matching with the answer what I have got. Don't worry about it. It's the same answer. It's going to be the same answer, but in a different format. Okay, so for the given question where we were trying to evaluate using cofactor, this is the answer or any other version of the same answer. Okay, in the next video we'll discuss about adjoint and how to find the inverse using this determinant method.